go to the agent code, right? Here's all the steps that you need to basically open those folder and then take a look at how is it. Oh yeah, one thing to take note is if you cannot see .env file because those are hidden by default, they're supposed to be secret, right? You can technically go to view menu, click on Kogor hidden files, then you should be able to see those view, right? So let me just quickly show you how it looks like. So in case, right? So by default, you should be only seeing this, right? So they'll be like, okay, you told me there are 3 files, now it's only 2 files, right? Don't worry, just click on view, Kogor hidden file. Then this is where you will see all these .virtual environment, .vs code, .env and so on. Okay, and click on individual file, and you can kind of see that this is the agent, right? Your agents using the model, the name is root agent because that's like the core, the main agent, and then your description, and then the instruction, right? So I kind of wrote down what each line means in detail. So in case you're interested, you can come to this code lab to see what it does and how it affects the agent integration or maybe behavior, right? So I'm not going to go through this just because we don't have much time here, right? But it's pretty much fairly straightforward to understand what it's trying to do, right? And we do need to have init.py because we're going to run the AI agent as a Python package, right? So if you do a Python package, you need to have that init file for it to be discovered, right? So that's how it is. And of course, we're going to be using Vertex AI, so we're going to have this project ID and project location, okay? So all these are actually input from you when you are creating the project, which is here, right? So I'm using, let's say, for AI agent, right? I'm going to just make it permanent here. So yeah, in case how do I make it permanent? Just double click on it and it should be good to go, right? So using 2.5 flash, right? You're using environment with my project ID and the location, right? So those are things that you just put in from the option and then you're good to go here, right? So the next step, right? So what do we do with this agent, right? Of course, we have the agent, we have to run it, right? So how do we run agents? Fairly straightforward as well. Instead of ADK create, you just put ADK run. So by using ADK run, it will run the agent directly on the terminal, right? So you might ask, why do I need to run it on terminal? Why not, something like a chatbot, right? So from here, I can say, hi, what can you do for me? Can you do for me? And then it should be able to respond what they do for you, right? You can see from here, it will respond back, based on things that you write down in the description, right? Okay, so why do we need to do this? Is that sometimes you're building an agent and then you might want to just have a quick test on whether the agent integration is okay, whether the agent responds correctly, stuff like that, right? So you don't want to then go into push into this code and then test it with the UI and stuff like that, right? You just want to have a quick test around and see whether all the connections are working, whether the backend is working, whether the two invocations are okay, stuff like that, right? So yeah, let's say we've already done all the tests that we need to do, and then we're like, okay, let's try to make it more like a development environment, right? I could just click type exit. So if you see, I type exit and then it should exit the terminal right away, right? So I'm going to clear this away so that you can see from here. Okay, so this is how you run the terminal, and here are all the steps that you need to do, right? And there's some troubleshooting steps as well, right? In case you say, oh, the API method require building, go to this page, try to choose it, and then try to link using Google Cloud Platform trial account. So you should be good to go from that end as well. In case you missed out the options to enable the AI platform, the Vertex AI API, although we do it twice, right? Just activate it one more time by doing this, and then you should be good to go. Right? So for some other errors, try reloading this whole shell, right? Have some cache or something that's not working. Just clear your browsing history, come back again.
And that's what the example story is. It lets you provide.
So
this is the terminal. Let me see if anyone can code without risking your core systems.
Let's see. Anyone having issues? All good. Could give me a thumbs up if you're okay. Following. Am I going too fast? Too slow? Give someone. Okay. Awesome, Chris. Thank you. All good. Yeah. Awesome. Right. Because it's really hard to kind of judge where you are because I don't see you on the left, so I kind of need some response from you.
It's a great example.
Make sure that your checkpoints are all good. Right. Yeah. So it should be fine. Right. Let's go on to the next one.
For more content from the Google
Cloud. Of course, after we've done this, right? The next step is okay, how do we then create a chatbot kind of experience, right? Because which user would like to talk to agent from the terminal? It's not possible, right? You can't ask somebody to talk to agent from terminal, right? You want to build something, right? So this is where we actually can test, right, the development UI. So it's also come together with ADK. All you need to do is type in ADK web. Slightly different from the way we are typing in initially, which was ADK run, then the agent name. And I will show you why is that, right? So if you type ADK web, what's going to happen is it will actually invoke the web UI backend. So technically, it's actually spinning up a web server. Like you can see from here, ADK web server has started, right? And of course, this is the local testing URL. And because we are running this server on the Cloud Shell, you cannot copy and paste, right? You have to do tunneling and stuff like that. But Cloud Shell has made it easier for you. All you have to do is by just pressing, control click or command click on this URL, it will actually help you to redirect to the chatbot directly. Like how awesome is that, right? You don't have to do any of the SSH channeling and stuff, right? You just have to click on it and then it will actually go here. And then here you can actually see the UI, right? And why we don't have to put any of the agent name is that these UIs allow you to switch between different agents that you're developing, right? So let's go back to here and see our folder structure, right? So you have ADK agents folder and you have this agent called personal assistant, right? If I ever have more than one agent, you should be able to choose different agents directly from here, right? So let's say you have 5 agents, you want to test it out and see which version works best, you can do it directly from here, right? If you do it through the terminal, and of course you have to like ADK run agent 1, right? Then you test it, then come back, exit, ADK run agent 2, exit, ADK 3 agent 2, right? So something like that is kind of like a lot of manual steps going on over here. Here's like very easy. You just have to choose different, right, kind of agent, okay? So from here, what can you do? The same thing, you can type, hi, what can you do? And then the agent should be able to respond back to you directly from the web UI. The nice thing is that all the markdown are also being formatted correctly. So you can kind of see its answer in a very good manner, whereby you see from here, I cleared already, but if you see from the terminal is very hard to read sometimes with all the markdown syntax, right? Here's kind of like more natural response, and you can of course talk to it. Okay. So that's the second step. And of course, I need to warn you, do not do the step 9. This is for people who just want to like, okay, I'm done with this, I'm going to quit, right? So we're going to continue with the next lab, right? So do not do this. I repeat again, do not do the step 9 because we want to continue with our lab, okay? So here I will pause a while to how to enable Gemini Coassist, right? Let's see. So this one actually don't have any Coassist enabled yet, but Coassist is more of like a different solution altogether. Okay, of course, you can actually do Gemini, right? So I don't want to confuse the rest of the folks. So I will try to answer and show you at the end of the session, right? So does it sound good, right? Right. Okay. So yeah, someone is actually going to the lab 2 already, right? So yeah, I'm really excited that some people are actually trying that too. I hope this was actually giving you some motivation to like, oh, I want to learn more. I want to build how agent works and stuff, right? I'm really excited as well. So let's quickly go into the second lab. So second lab itself, you see from here. So this is actually the second lab. We're going to start using tools, right? So remember the one that we cover, we have agents, large language model, and tools, right? So this is the lab that you will be using for the second one. Yeah, so there's some people saying some labs and all that. Don't worry, I will actually go through the lab with you so that you kind of know. Okay, so ADK using tools, but the error that you encounter next, if you use the latest version of Google ADK, it should have solved already, unless you are using different Python version, right? So I'll also show you how to actually mitigate that issues. But let's go through the content first, and of course I will leave some time to go through some of the custom questions that you're asking as well, right? So with time in place, let's actually go through the second lab. Okay, so this is the second lab. It's about empowering with tools. So before you begin, you probably do this already because we are on the row of doing from lab 1 to lab 2, right? So what we need to do now is that they say let's create a base agent, which probably did because they are part 1 and part 2. You are continuing from the foundation code lab, so you can skip ahead to the 4. Okay, so we will be starting from the step 4 of the second lab, which is empowering with tools. Okay, so what are tools? Like for example, right now we have this agent that we just built. So the agent has the LMM, right, but no tools. If you realize, let's go to the code one more time, right? So this is our agent code, right? I'm gonna just zoom in a little bit so that it's easier for other people to see. I'm gonna close this, code assist thing going on over here. Here's what it looks like, right? So you have the model, you have the name, description, instruction, but we don't have any tools. So if I ask something like, what's the weather like for tomorrow in, I don't know, Singapore, and it should technically say, I can't really provide real-time info because I have no access to the internet, right? Or I have access to my large language model, and I know that because this is the large language model only, I can't retrieve any of the real-time info. Maybe we can try something like what's the exchange rate between USD and LGD, which is Singapore dollars, right? And it will just say that it will there's a range that I can kind of say, but I cannot provide real-time info, right? So it kind of fluctuates all the time. So this is the retrieval part comes in, right? We need to give our agents a way to retrieve this kind of real-time data through a trusted information, right? So maybe if you're building it for your company, you have like a database or API or systems or something that can retrieve those info for you, and then your agents can answer those on your behalf, right? So this is what we will explore for the lab, okay? What I will do now, I'm going to stop this. So to stop that, you can just press Control-C from here. So both Mac and Windows, Control-C actually stop the process that's running. And what we need to do is we're going to do this thing called custom function, right? Assuming, I am building an exchange rate chatbot, right? And I know exactly where to get the exchange rate. And, my company do with this kind of business. So I have this API that I trust, and we already have an existing way to get those rates. How do I then integrate this to my agent, right? So to do that, we just need to create this file where it's called custom function.py. How do we do that? I will just type in this command. So touch actually create an empty file. Okay, so just click copy, then come here and then type it in. So what's going to happen? It's going to create a file which is empty inside our folder, right? So you can see from here, it's totally empty. There's nothing going on over here, right? So what we need to fill this up with is a function, the Python function that query the data from a website, right? So I'm going to use this free API that's available, right? I'm going to put in like base and the target. One important thing here is the doc string. So this is like a documentation for your functions, right? Why this important is that when you pass this, Python function as a tool or large language model, the first thing it will do is to read the documentation, right? Stuff like, oh, if you put base, what kind of info do I need to put inside the base? What kind of info do I need to put inside target, right? That's why I'm providing things like example here, right? And what does it actually return, right? Where you return none, where you return an error, stuff like that, you should put it down here so that the model that is invoking the tools can understand what happened when something happened. Okay, that makes sense. And of course, that was like a big piece of text for a function. The whole function code is just here: base URL, API, user request, get the API. If we receive 200, just reply the response, right? So it's all it does is to query the API. Very similar to how we've been doing in the past. So what I'm going to do is just going to copy this, then paste it back into custom function, right? So here what we do, okay? So if I'm doing too slow, please bear with me. Some people sometimes take some time to adjust. So just to make sure everyone's on the page, I'm going to do that. And here I copy, and then what we're going to do, we're going to just change our agent.py. Okay, so we have this new file. So now we need to link that file into our agent, right? So that the agent have access to the tools, right? So we're just going to change our function a little bit, copy this, then go back to our agent.py, and I'm going to just overwrite the function, right? So you can see from here, I'm just importing ADK tools fun tool, then I will just creating fun tools from the get fx rate, then just passing in as a tool. That's all it does, right? So now, how do I test it? I will just do, I'm just going to clear it away. I'm just going to do ADK web one more time, right? So I'm going to close this one. Then it will spin up another instance, right? So for some reasons, your port 80 is occupied, stuff like that, right? How you can do it is to try to kill whatever that is there in the port 8000, right? And then you can actually see, right? You can try this web preview as well, right? Preview, and then you can see the web preview as well. But I hope everyone should be able to run this one. If you're having issues, just stay back later and we'll try to resolve that, right? So for the most part, should be fine. Now, what I can do with this agent is I can ask for the exchange rate, right? What's the exchange rate between USD and LGD, right? So what's going to happen at the backend is going to call the functions called getFX, get a rate, and then give you a rate. That's it, straightforward, right? So whatever function that you provided, right, you just have to put it in a function. So just wrap it. So just recap the code here. You just have to create a Python function, right? Then you wrap it with function tools that is provided by the ADK, and then suddenly your agents can use that function to get the data and then present it to the user, right? So that's the power of creating agents, right? So now agents can actually use the function on your behalf to do things that you want it to do. Okay, so let's go back to our code, right? Our code lab, and see this is exactly what I was writing here, right? So assuming this is only for currency exchange, what happens if I want to, let's say, ask for weather update, ask for a trip, ask for, what's the price of the accommodations, right? So those are also real-time value, right? And you can't be writing every functions for every single thing that requires internet, right? Maybe some you really need to be very accurate, like, exchange rate, right? You might want to create a custom functions and you kind of like give it more importance so that you can actually get it from the trusted source. But something like, weather information, like the review of restaurants, right? You don't really need to write a functions to be very clear, right? You can technically go to the website, right? Maybe Google search and then search for it, right? So those are like not very important to be like so accurate because they're not like groundbreaking kind of thing. So how do we do that? ADK actually provide a way for you to integrate Google search directly into the tool itself, right? So what we can do is all we need to do is just to put in, let's say, something like ADK tools, Google search, and then you just pass in Google search directly inside, and that should actually work, right? So let me see, right? So here I can ask things like, what is the weather going to be like in Singapore tomorrow? it should tell me that I don't have access to real time, see something like that, right? So I'm going to take a stock of this instance. I'm going to change the agent.py code by copying the code over here. So Max said there's some error, so let me see whether I will encounter that, right? So what I'm going to do, same thing, I'm going to clear this one, then do ADK web, right? So I'm going to close this so everything is clear, right? So what we just did, we just passed in Google Search that is built in as a tool, right, to our agent. So let's see. So from here, I will now type what is the weather like for Singapore tomorrow. I hope I don't encounter error. So okay, there's an error here, right? So okay, so what happened here is that sometimes there's some restriction, right? So multiple tools are supported only when they are all such tools. So what we need to do is we have to break it out, right? So assuming you have one big agent that doing 20, 30 things, right? So some of the things might actually be redundant. Some of the things might be, it could go either way, right? For example, let's say you have the Google Search tools and then you have the, let's say, weather forecast tool. Which tools is more important? Like you need to define it, right? So, and also it's also good to broken down into like by responsibility so that your agents are not overloaded, right? Because you have one main agent and all your customers are talking to this main agent, it's kind of hard to respond all the time because you just like bottleneck in that one big agent, right? So what we can do is we can actually adopt this particular approach where we do multi-agent, right? So this is like one step into multi-agents, right? So how we're going to do is we have to actually break it off, right? So how we need to break it off is by creating something called a Google Search agent, right? So what we're going to do, I will try to put that code in later, right? Maybe I will just send it through to Bill to like put this code, right? I actually added the code in, but maybe the update is not yet updated, right? So what we need to do is we need to actually create this agent. Let me just copy this agent, right? So what we need to do is just create another agent. Let's call it Google Search Agent, right? And then Google Search Agents will use Gemini 2.5 Flash. Same thing. We're just going to name this Google Search Agent, okay? And then the description, everything you can just say that this is helpful, Google Search Assistance, blah blah blah. Use rest of your knowledge, right? And then I just remove the function 2 from here. So this Google Search Agent is specialized agent that can only use Google Search. And you can actually use this Google Search as like a child agent or like a dedicated agent inside your root agent, right? So how we would do that? Let's say from google.adk.tools, from there's like agent tools. So there's agent tool here, and you just import agent tool. Okay. So from the function, custom function, you import function tools. If you want to attach an agent, you import agent tool, right? This code is not in the code lab. I will try to update it, and you should be able to see reflected in like 1 or 2 days, right? So agent tools, I just wrap here. Agent tools, then I will say this is a Google Search agent. Okay, so just do Google Search agent over here. Right. So from here, you have root agent that has access to your function tool that has calling the custom function of get FX rate. You have the agent tool that is able to delegate stuff to Google Search agent, which is also an agent. The only difference is that it has access to Google Search tools. Right. I'm actually trying to record this by memory and live coding. Right. So bear with me if this doesn't work out the first try, but let's see whether that works. All right. I'm going to try ADK web one more time. But let's see whether that works. All right, I'm going to try ADK web one more time, and hopefully this time around it should be good. Okay, so I'm going to ask again, what is the weather like in Singapore tomorrow? Google Search agent is not defined. Let's see. So what I need to do is probably to create another file, right? So right, Google Search is not defined, right? Maybe we can here import from .import Google Search agent. Okay, let's try this. If it doesn't work, I will try to fix it. I promise, and I will send the code to Bill. Right. So let's try one more time. The last chance. If not, then we will proceed on the next one. Right. Okay. What is the weather? Did this one already? Let me just check. What is the weather like tomorrow in Singapore? No. Okay. So then we probably have to create another files to pretty much just do that. So let me just do it. Create a file called custom agent.py. Then I paste the code. So I don't need this anymore. I just create this agent code. Right. So from here, Google Search agent has to be in another code here. Then I will just import what I need from here. So I need to do this. And of course, I need to do this as well. Then I can import that directly into from.custom agent, import Google Search agent. Okay, so now we have Google Search agent that's imported by another file, which is called custom agent. Okay, so custom agent code has the Google Search agent and it has access to Google Search. Right, let's try if this works, right? I hope it works really. If not, then they probably change the code, which I'm not aware of. Bear with me. Apologies for the error, but let's see, right? If this works, I really like the round of applause, right? Let's see. Okay, what is the weather like for Singapore tomorrow? Right, so no error, good sign. Let's see what the agent does, okay? So what's going to happen is now it's actually delegating the task. You can see it's delegating the task to Google Search Agent, and then Google Search Agent actually reply back to you. What's the weather like for Singapore tomorrow? And of course, now you can ask like, oh, what is the currency exchange between USD and that's like AUD, right? And because this is currency things, it knows that your custom functions should be able to respond it, and then you trust this source more than Google Search, right? So it will actually use Google Search Agent and then also use the database route, right? So it is know what to route to, right? If you're asking general internet questions, it will delegate tasks to Google Search Agent. At the same time, if you are asking currency rate, they will actually get the currency rate using your custom function. So for clear, right? Yeah. So yeah, I mean, someone say that that's agent. Okay, some error, right? How do you know which one should pick? Okay, so I will cover from the start, right? Someone asked about. Right. Someone asked, okay, I hope you have time. Yeah, I tried my best. We are kind of running out of time, so you might have to do that A2A lab is a little bit. Okay, so now does agent build with ADK communicate by A2A? So agent build with ADK is very much just agent, and the protocol of A2A or A2C, you have to implement it yourself. But A2A has like better support because that's how kind of work together. But you don't have to use A2A to communicate with agents because agents are supposed to be agnostic in terms of the protocol, right? So as long as you are implementing the protocol correctly, you should be able to communicate, right? Yeah, correct. In the new agent definition, don't have instruction string. Yeah, that's right. So when I was building the agent, you can ignore the instruction string because it's going to read the instruction from the delegated agents, right? So I will go through. It's actually similar to the question that someone asked about how to know which one to pick, right? So let's see. Okay, let's answer that question. Here, when we are writing the function, right? Okay, let me just go down here. When we are writing the function, we just put it down here like very clearly on this function is exactly to check for currency. Right. So as long as you're putting currency, this is going to get hit first because in our agent, it just use Google Search to find info, right? This is like very clear. So that's why when you are creating custom functions or some of the functions that you pass into LLM, it's very important to put very clear wordings of when to use, what to use, right? So then the question arises of okay, if I have like 2 or 3 similar tools, how can I make sure that they use the right tool all the time? So then you need to revise your architecture, right? Like why do you have 3 similar tools in one agent, right? That sounds to me more like a business problem than a technical problem. You should only have 1 tool that do the task well, right? So you shouldn't have like many other tools that doing the similar thing, right? Like web search, Google search, right? Web scraping tools. So which one? Like just make up your mind, right? Maybe when we go through the workflow agent or that you might cannot have like different ways to like maybe pull some data in, right? So that's how the ADK actually designed to be used, right? When you put in a very clear doc string in the functions or instruction in your delegated agent. Okay. So Aram asked how ADK is different from Crew AI and LangGraph. Yeah, so ADK is like very similar, but it's kind of like different. I would say phone provider or something like that, right? So see, ADK is open source, that built by Google. So most of the Google toolings will have like first person approach, right? Like I say, you can connect up to BigQuery, you can connect up to A2A very easily, right? So maybe like Crew AI is like maybe open source somewhere else, and then LangGraph also open source somewhere else. They have their own ways to do things, and through protocol like A2A, MCP, something like that, you can actually talk to each other very well, right? Depends on how and when you're using it, and like what kind of methodology you use. Like for example, we just go through some of the like nuance of architecture, right? So LangGraph have this thing called a time jump where you can like jump through different agent, different steps. Crew AI doesn't believe in looping, so it's kind of like going through step by step, things like that. There's some methodologies, architecture constraint that you have to like kind of see which one actually fit your use case. Okay. So someone asked again about is dot string every time? Google Search doesn't have a dot string, so Google Search actually have instruction and description, right? So it's kind of like replaces the dot string for some cases, right? And of course, the Google Search tools inside also have dot string, but we can't see because it's a built-in tools, right? But the codes are open source. You kind of like go to the source code itself and see how they implement Google Search, right? If I'm not wrong, just calling an API at the backend. Yeah. So that's how people do it. Some Namdi, sorry if I'm pronouncing your name wrongly. So some, like he said, seen past ADK webinar where they put sub agent in a folder actually as a package. Is it necessary, right? So it depends on how complex your agents are, right? Because if you have, let's say, one particular module that does, let's say, all the booking to the hotel, right? Then you might have different agents that work with different, provider, different, let's say Marriott is one, like a Grand Hyatt is one, something like that. Then you probably want to like put them into a package called hotel, right? Like hotels and like hotel agents like Marriott agent, Grand Hyatt agent, something like that. So users asking like, okay, I only want hotel result from Marriott. Okay, then you probably just delegate the task to Marriott agent within the same package, right? But if you are doing something very similar, very simple, something like this, you don't have to then create different folder, but it's similar to how Python packages are maintained as well, right? As you have more and more agents, it's kind of hard to maintain, and also like it's hard to kind of like control like versioning and all that things. Like maybe you have like 2-3 different developers working on different type of agents. They should be sharing like one file, right? Then you have to like make a decisions on like, okay, let's create a folder, then make a package, and then you split the file accordingly, something like that, right? So these are all architecture kind of like questions, right? So another one's agent tools method similar to A2A protocol somehow. It's slightly different, right? Because A2A methods require you to create like agent cards and all sort of things, which I don't know whether we have time to go through. But let's see. Okay, one last questions. After that, we're gonna go to the next lab. Okay. So does ADK has facility to evaluate agent performance? Okay. So the thing is, we have evaluation matrices, but we probably won't have the matrices for like every individual use cases that you have, right? Definitely, of course, sometimes you might have a very niche use case that you need to test, right? So then, of course, we don't have that, and you have to create the test cases yourself. But we do have the facilitation to evaluate stuff like that, right? Okay, so is there a guardrail feature built in? I don't think we have guardrail feature built in, unless I haven't been updated myself with like, the latest update that they have. So they might have the guardrail for the Python package that connect up to the Gemini CLI or Gemini API directly, so we can explore that approach. Someone asked about observability, right? Okay, so yeah, we just go through and I show the code, right? Observability, you have some ways that you can actually integrate with like cloud logging and stuff like that on Google Cloud, right? Because ADK is open source, so if you are only going to install the package on your own laptop, and of course you probably don't have ways to like store the memory and stuff like that, because then you need to create like different instances to store those memory and all this. I think OpenTelemetry might be supported. Let me go and find the documentation. If I find it, I will send it through Bill so that you can kind of see it from the chat as well. Another one's okay, how do you do result validations, right? Is it for fuzz routing without LMM, right? So that's the next lab actually that I want to cover, right? Let's see. I think I should have time to cover that workflow agent, right? So I will just go and show the python.py code, right? So here is how it looks like. Let me just go down, right? I am just importing the custom agent. So I created a file, right? And I wrote my Google search agent, right? Then I wrap it with the agent tool wrapper, right? So Google ADK actually provide agent tools. I wrap it and then just pass in to the function directly. So from root agent perspective, I have access to two tools, right? Just that one of the tools is agent, right? So I'm like dedicating, right? So let's go back to the slides, right? So if you recall this one, right? Your tools can be agent as well. Remember? So tools can be agent. So if the tool is agent, what they do is they do delegation, right? So they will just pass in the necessary information for the agent to perform the task. Then they just wait for the results, right? So there are a few ways that you can actually improve the accuracy, latency by having like a parallel tool callings and stuff like that. Those are a little bit advanced, and we definitely don't have the time to cover it today. But I do encourage you to explore if you are really interested in it, right? Yeah, those are like fairly advanced topic where you're like optimizing the agent invocation, delegation, latency between delegation versus invoking the tool, things like that, right? Okay, so let's quickly finish up our second lab because I do want to cover the workflow agents and so on, right? So this is what the Google search agent looks like, right? Oh, actually here, I forgot about that, right? You do have another way, which I just did, right? I thought I couldn't push this update for some reason, but you have here. This is how you would do it, right? All the agents you just pass in here, then you just put it in here, then yeah. This is how you can actually do that, okay? So now we move on, right? So someone asked about LangGraph, someone asked about CrewAI, right? We actually support those tools. We call them third-party tools in ADK as well, right? So if you already built some of the agents from the CrewAI or maybe the LangGraph, LangChain community tools, right? They have like tools to scrape the web or like get the map API, stuff like that, right? You can actually use it inside ADK as well, okay? So how do we do that? We just have to, let's say, install the package that you want. So here is what the example I use here is like a history, right? Google search is good for finding things that is not necessarily need to be like very, very accurate, right? Like what's the difference between, like 22 degrees Celsius and like 22.5 degrees Celsius? It's very easy, right? Like you don't have to then like care too much about like the minute details of the accuracy, right? But what if I really need something that should be very accurate and like very linear, something like a history, right? Like of course I can't create a summary of a history of a town that is written by like 20 different people all over the world, right? You need like a trust tool source, right? And of course you can also write functions and then pull that data from your database. Maybe your company is working with something like a tourism kind of thing, right? You could do that. But for now, I'm going to demonstrate how you can actually use Wikipedia tools from LangChain, right? So if you are building some agent with LangGraph, you could already use whatever tool that you're familiar with in the ADK as well, right? So to do that, I'm going to just stop here. Then we'll just copy it, then install, right? Why do we need to install? Is because those LangChain tools and everything are actually Python packages which we haven't installed in our local environment, right? So we just install it and then see, right? So UV like super fast. That's something I like about UV. So now it's already inside, right? What we need to do now is to create a file called third-party tools. I'm going to just copy this, create it here, okay? So then you can see it created an empty file here. And I will show you what the content of the file looks like, right? So I'm going to just import LangChain community tools. So here's like Wikipedia query run and then an API wrapper, right? So in this case, I only know that there's only one history page on Wikipedia, right? Sometimes, depends on some website, you might actually have like different pages, right? Maybe you are referring to maybe research, right? Then of course, research paper might have like 20 pages. You might want to read the entire 20 pages, right? And here, I'm just only going to read the top results from the API itself. Then I'm only going to do the 3,000 character read, right? I mean, of course, you can play around and change the value and all that. And the important part is here, right? I'm actually asking, or rather like defining that, hey, provide the deep historical and cultural information. Use these tools for tell me about or what's the history of type of questions, okay? I'm defining very clearly in the description that these tools should be used if the user asks, tell me about or what's the history, right? If anything other than that, you can use Google search or whatever that you have. But if the question is about tell me about or history, use these tools, right? So that's how you actually guide the LMM to choose the right tool for the right task, right? You need to give them example. You need to give them very clear direction, right? Even if you cannot decide, how you ask the agent to decide for you, right? You have to be able to, from a human perspective, you should be able to tell exactly when to use these tools, right? If you already do not know, then there's no way agent will know because you have to then define all the logics into this, right? So I'm going to just copy this and then create it into this third-party tools file, right? Same thing. I need to update my agent.py. So how do we update the agent.py? Is by doing this. I'm going to just copy this. Right here, I'm just importing LangChain tools directly from Google ADK tools, right? And then of course I import third-party tools. Then I have integrated into agent tool and then wrap it with the LangChain tools, right? So now we have 3 tools. And each are imported from different files and then wrap it with the different types of tools, okay? So this is just an example, right? You might not have all 3 tools in your own project, but it's completely okay, right? So I'm gonna copy this and change my agent. And I do have to be careful because I forgot to put an S in my files here, right? So I just remove the S. You probably don't have to do that, okay? So now we have access to LangChain 2. I'm gonna just do ADK web here to start an instance, right? Then you will see the ADK web instance coming up, right? So here we can ask the first question, right? Tell me about, Kyoto history or something, right? So if you ask, tell me about questions, it should use LangChain tools, which is Wikipedia, right? And then if I ask about what is the currency exchange between, let's just say SGD to JPY, right? We're going to Japan, right? Let's just try it. And because this is a currency exchange task, it should use get FX rate. And then, come down to weather question, right? What is the weather for tomorrow in Singapore? Because this is general questions, it should use, kind of weather focus. Okay, let's see. Somehow something goes wrong. Maybe, because I forgot to authorize it. Right, let's try one more time. If not, then let's just see whether the agent activation works or not. Right. Maybe, yeah, I think it should be okay. Let's try it one more time for the goodness sake. Right, let's just try what is the weather like in Singapore tomorrow. It should use Google search this time around. But for some reason, it's not using Google search. Right, okay, maybe there's some things I need to do that I forgot to do it. But yeah, you should technically be able to switch it around, whether dedicating tasks or doing the currency exchange and also the Wikipedia thing, right? So you can say, tell me about Singapore history, right? Then it should actually use the Wikipedia to get info, right? So that's pretty much how you can do that. And one thing that I also want to show you, right, because this UI have built in so many things, you can technically see the events, right? You can see from here that it's invoked, it called the API, and then the LLM itself, it returned many things, right? You can see from here that what's the signature? Oh, okay, I think I haven't authorized. I don't know why it keeps asking me to authorize, but let's see one more time. Okay, I got to close it and come back again. Maybe restart. So this kind of thing happened. The safest thing is just to reload, right? And it will actually provision your culture again. Then you can start again, right? Hopefully it doesn't. Ask me to authorize again. ADK what? Here, ADK what? Okay. Let's see. It should open up. Then let's try what. Tell me about the history of Singapore. Okay, now it should actually work. Let's see. Okay, so now you do this, sending out. Then there you go. It's using Wikipedia, right? So what's so good about it is you can actually see the invocation, like when it called the LMM, when it's execute, right? And like you can see from the request, right? Like this is what is returned. So remember, we are actually using page 1, 3,000 keywords. So you can see that 3,000 keywords from here. And of course, that 3,000 keyword is not the ones that written here. It kind of rephrase it in a way that is complete, right? So, and you can actually debug very clearly from here, like what being returned from the tools, what kind of requests you have, and also you can also go through some of the events, right? Like you did a function called Wikipedia. You can actually click on it and see how many tools are there. Where does it come from? Like for example, like the step 1, the event step 1, the root agent actually calling the Wikipedia. Then the step 2, the Wikipedia actually returning back to the root agent, right? You can see on the arrow here. And step 3, of course, the root agent internalization is, and then return the results, right? So you can like very easy to debug which tools return what and what is being called, right? What kind of function is being calling? What's the query, right? What's the name of the tools, right? What kind of test? Maybe like you integrated some tools in AI that return you maybe images, video, etc. Right? Because Gemini is multimodal, you could do that. You can see from here the modality is text, but it could be more, right? Maybe it's a video, maybe it's an image. You can kind of see it from here. And one important thing that's very important is this is not the UI that you interface to a user. right? This is for developer to debug and see all the stakes, all the sessions. There's evaluation matrices, right? You can actually create evaluation set and all that. Someone asked about that as well, right? You can also trace what kind of invocation, how long does it take to kind of dedicate a task, call the API, and so on, right? But this, I repeat again, this is not the user interface that you want to expose to. This is for internal only, maybe for development purposes. You will debug and create applications and implement new features here. Then you will actually start something like a web server separately, and then you have your own interface that is maybe a chatbot that you can from your company website that is linked to this backend. Okay, this is not for user. Okay, I repeat again because I see some people do that. Okay. So that was pretty much two callings. Let's see. There's some people asking questions about. Okay. Yeah. So someone asked the question again. So I think I need to go and check the new ways to call those agents now. Probably because my instruction is not very clear, right? So they say for dev from non-English speaking country, is there a way you can generate better prompt? Okay. So one question at a time. Let's try to answer around. If you're not speaking English, is there a way that you can generate better prompt instructions? Let's see. Yeah. Let's try to use our agent to do that, right? So let's say this is prompt, right? So just example, okay. Translate this prompt to I don't know France. Let's see, maybe not French, maybe Chinese, right? I don't know. Let's see. So typically you could get this kind of responses, but I need to warn you one, because I'm not a Chinese expert, right? Sometimes, the ways you structure your language, right? Maybe subject, verb, object kind of thing. It makes more sense to put some emphasis before and after. So there's some nuance of the language that you need to learn when you're building instructions or when you're building a prompt. Okay, I have not seen like language-specific optimizer, but we do have prompt optimizer on Vertex AI that you can make use of to like expand your prompt and ask the agent to write a better prompt. So it's kind of like current state. There's like maybe try and error kind of things to make sure that your language that you're using is kind of like aligned, right? Like for example, my native language Burmese is like subject, object, and verb, right? And if I translate it from English, it could be subject, verb, and object. Then it's kind of like doesn't make sense to some degree, right? So you need to make sure that the language that you translate actually makes sense for the language of origin and see whether that actually makes some differences. Okay, right? Is the monitoring options, token expenses? They do have. You can see from the event itself to see how much token, right? Prompt token count and like total token count and so on here. It doesn't have a money value tied to this because you can use more than Gemini model in here, right? You can use your own custom model. You can use some model that is hosted somewhere else. So it's very hard to tell you exactly how much it will cost, but you can do total token count over here and see how much it's likely going to cost you, right? So you can go through some of the scenario and then see how much token is consumed, right? Yeah, I don't have much time, so maybe I will answer some of the things. So the things, there's a monitor option. Yeah, I answered already. So there's like Google Cloud CLI is working, and I create a new file, but can't copy to the console. Yeah, so I don't know what you mean, but like you cannot copy to here. Could be a few ways, right? Let's just assume that your session is timed out already, right? So what I would recommend, restart, right? So just restart, reload the session, and see whether you can paste or not. But some authorance, your laptop has some prompt guard that you cannot copy some things because they want to prevent you from exposing company secrets to some other places. So that one I cannot help you. You probably have to go and check your IT whether you have that kind of restriction or not. Yeah, so try restarting first and see that actually solve it. If not, then that probably restriction from your side, right? So the next one, how do you configure the agent so that you can call it from an API, right? So there's actually one specific ways to run it. I will actually go through that in the documentation later, so you will see how to run that, right? So it's actually kind of like a node server thing when you just host it and then it will just spin up a node server and give you an API key, right? That's like pretty much what you are, how do I say, you're hosting it by yourself, right? But of course, if you're using Google Cloud, then you can actually deploy it to something like Cloud Run or like an agent engine where it will take care of all the hostings and like exposing the API link for you, right? So those are fairly easy steps to do as well. It's more like, ADK, run, deploy, Google Cloud Run or something. And that's how like, you can easily deploy it to Cloud Run, right? But I do need to kind of wrap it up. So let me quickly go through. So this is something that we went through already, right? So you can see from here, that's pretty much what we went through. You can see the event expose, but don't expose this front end to the user. That's pretty much it, right? Okay, so this is the end of lab 2, right? I probably don't have the time to do the lab 3, but I do want to cover some of the theory, right? So let's go ahead and cover the theory, and I will leave maybe like last 5 minutes for us to go through some of the questions that we may have. Okay, so coming back here, right? So someone asked, right? Maybe not every time we need large language model to come in and decide what's good for us and what kind of workflow to be done, right? So good thing is that ADK actually have different types of agent, right? Fairly good. We have large language model based agent, which you just experience, right? What it does is whenever the user prompts something, it will move or route the prompt to the large language model, and then large language model process it, generate response. It will actually pass that response back to the user, right? So it makes use of large language model as a brain to operate, right? Reason, plan, generate, and so on. But sometimes you don't always need the large language model to give you, right? Maybe something like user asking for their personal info, or like user user logged in, yes or no kind of thing. Then of course you don't need to have a large language model, right? You just have to check the status. For example, you just want to maybe plan out some of the fixed workflow, right? Let's say your user asks to extract customer info, like their own info from your database, right? Then the step will be like extract the user information, maybe like check whether user authenticated, extract user information, generate SQL statement, query the SQL statement to the database, return the result from the database, like validate whether the database is clean or like authenticated, or make sure the data we retrieve is like relevant, sanitized, blah, blah. Then you do evaluation, then you send it back to the user. Right? So those steps are the same regardless which user actually querying, right? So it doesn't matter who query it. I have to go through all these steps anyway. So it doesn't make sense to be decided by the LLM because those steps are fixed, right? Like I want to be done in this way, and I want my agent to go through the same way that I do right now, right? So how do we do that? So here's the 3 kind of agents that you can use, right? So one, we call these agents workflow agent. Like one is sequential agent, where you can put things in sequence. So you can have, let's say, like Google search agent, you have planning agent, you have Google search agent, research agent, writing agents, validation agent. So they could be in all one sequential. So agent 1 activated first, followed by agent 2, agent 3, and agent 4, right? And those execution is handled by this workflow agent that can actually pass in, let's say, one input, input from output from agent 1 go into as an input for agent 2 and so on, right? Of course, those are like sequential one. But sometimes you can actually optimize it, or maybe even prefer it to be do in parallel, right? So things like searching for cheapest ticket, right? You don't have to go through one website, search for it, second website, search for it, third website, search for it, right? You could just ask the agent to go everywhere, look for that flight tickets, and then return back to me so that I can make an informed decision, right? I will want them to go through as many as parallel as possible so that I have all the data that I need before I come back, right? So this is why you use something like parallel agent, right? You want to run the agents to be in parallel. And the next one is sometimes you want to actually go through, right? Let's say, for example, I'm searching for information, right? The first thing that I search will be like, okay, go to, let's say, I have like 20 websites to search, but I know that most of the time I can find it in the top 5 websites. So I was like, ask the question, right? Go to these 5 websites, look for the information, right? And then the agent come back and he say, oh, sorry, I don't find the information. Okay. So then, okay, if I didn't have a way for them to like re-invoke, right? Then I have to then come in, take a look at it, re-invoke, and then like, every time the agent finish, it should be a way for it to like check whether they have performed the task already or not. If they complete the task, then they stop. If not, it should just go back one more round to search, right? Maybe expand from 5 websites to 10, 15, 20, and so on. So this is where the loop agent comes in. You can use the loop agent to do all these things. Okay. So this is like a typical design of the sequential agent. You have one input, one output. The input actually flow through agent 1, agent 2, and so on, right? And the arrow indicates the execution and then not the state share. So that means that, let's say the input 1 is accessible to agent 2. You have to design in a way that they are sharing some states, right? So we call it agent states. If you are designing a system where all the agents have access to the same input or like the same information, you need to design in a way that it can be shared, right? So the next one is parallel, right? So the parallel one is that one input that through every single agent that you have, in a way they are kind of like having their own input. Then whatever agent amount that you have, that is the equivalent of whatever output you have, right? So maybe you're searching for booking, and then maybe agent 1 come back with 5 booking, agent 2 come up with 2 booking, agent 3 come up with 0 booking. From here, you can then consolidate them into like another workflow to kind of see which one is the cheapest, which one is the the easiest to go, stuff like that, right? And then this one is the loop agent, right? So loop agent is similar to the sequential one, right? So from 1, 2, 3, 4, it kind of go down step by step, just that it has the loop parameter, right? So how many times I can go back to the step 1 to actually execute those, then I can call it quit, right? So there are 2 ways to quit this loop agent. So one is through defining the number of iteration you allow it to move. The second is to have the exit condition. So right, let's say I put max iteration of 5, and by the time it has finished iteration 3, it's already complete all the tasks that I'm supposed to I asked it to complete. Then it shouldn't just go a few more rounds, right? It should just exit. Okay, so this is something similar to if your machine learning is like early stopping, right? So depending on the condition, it will stop early, even if you put maximum number of 2, right? And of course, if you put it like 9999 and then the exit condition is never met, it's going to run that 999 times until it's actually finished, right? So it's either or. It's whether the exit condition met already, or you have to go through this entire mass iteration defined here, right? So same here, one input, one output. Okay. So you might ask, right, we already have LLM agents, right? And why do we need to have workflow agent? Because that is similar to like if-else statement and all sorts of things. You'll be right, because workflow agents actually provide you a few things, right? One is reliability and predictability, right? So like if you want this flow to be done in this way, you can be very sure that the workflow agent would do in that way, right? If you put workflow agent like sequential agent, things will be running sequential, no doubt about that, right? There's no way that like 99% I run sequential and then 1% I run parallel. It is not going to happen because it's designed to be reliable and predictable, right? And also it also provides some kind of structure. So whenever you want to design an agent, right, you can't have very fuzzy logic built in, right? There cannot be every single turning point is fuzzy, because then you don't know which path the agent is going to take, and it's very hard to debug. At the same time, it's very hard to start building things on top, because you're building on like not 100% things on top another not 100% things, and machine learnings are already not 100% to begin with, and your system will be like very shaky, right? So stuff like that, right? That's why we need some kind of stability to be introduced into agent systems. Okay, hope that's clear. Yeah, so this is actually a code lab. This is actually a notebook. Actually, it's not a code lab. If you want to, you can give it a try and see how you can integrate those workflow agents into different workflow agents, sequential, parallels, and loop. And another one is the ADK one. ADK one is more of like how to use with MCP, how to use with ADK, right? So like you have agents here already, how to then communicate with different agents all together, stuff like that. Someone actually requested to cover a little bit, so I will try to cover that. Maybe I just open this up and show you what exactly it looks like, right? You can see from here. Okay, so we just created an agent, right? Don't worry about all the text and all that. I just want to explain with the diagram that we have here, right? So MCP and A2A, are they similar, right? They're similar in the sense, but they have their uses, right? So if you have agents and you have like agents here, maybe workflow agents have like different agents that is listed down all here, and then you can use MCP to communicate with like APIs, like the what's it called? The currency API that we write, or maybe like a LangChain API that we actually invoke. You can use MCP to do that, and you can actually use A2A to communicate with different agents, even if they are using different agent framework, right? Maybe you have agents that's built with CrewAI or like LangGraph. You can implement the protocol for them to talk to each other, right? So how does it look like? It actually look like this, right? So whenever you go to, let's say, networking sessions or like some of the networking or like career events, you probably bring a name card or like your CV, right? It's similar to how it works. Okay. So they have this thing called agent card. So agent card contains the capability of the agent, right? But not all model understand image, text, audio, right? So maybe bare minimum, the agent will understand text communication. And even someone asked about local languages, right? Maybe not all model can understand, like a Mandarin or like a France, or maybe even like, like a German or something like that. Maybe only talk English, right? So stuff like that, you can have to like put it down here so that whenever 2 agents are communicating, right? Let's say agent A, that created by me, can only speak English, right? Can only communicate through text, right? And I have some skills that, maybe I can tell you the weather information, I can tell you a joke, something like that, right? And also like here is like where you can actually reach, right? What kind of authentication method that I accept, something like that, right? So this is more like some like name card where I will share with another agent when they come to communicate with me, right? So maybe another agent that maybe you built, right? And then your agent is so advanced that you can actually understand your audio, video, image, you can respond back in multiple languages, right? You have different skill to do many different things. But when my agents and your agent talk to each other, they have to agree on the way that they should communicate, right? Because my agent can only communicate through text. The other agents that you built should only talk to me in text. Because if you send me audio, image, I cannot understand, right? Maybe even like different language, I cannot understand. Because all I can do is, just read the text in English. something like that, right? So this is something like where you put a name card and then list down the things that you're providing, right? Something like your CV or something like that. So this is how A2A works, right? Regardless which framework you use to build this agent, you can actually start creating this agent card. It's a JSON format, right? Just put it at a JSON and then using the framework to make it able to communicate with each other, right? I hope that kind of explains it. Let me see. Something someone asking about the client error. So the client error, right? I actually write down some of the fix that you have. You probably need to do activation of the Vertex AI API, right? So Aram asks, does workflow agent is something like an agent mesh orchestration? Okay, yeah, so one question is this is orchestration? That's right. So workflow agents are for agent orchestration, right? Like how would you invoke a swarm of agents in a collaborative manner, something like that? And also, do we need to build agent gateway in agent system? Design just have API gateway. Yeah, so you could technically have like API gateway and then have the agent talk to them. But with the agent, right, what most of the people does is they will just create MCP or like a A2A kind of protocol so that you don't have to then do the API thing, right? So if you're doing API, then I got to wrap it with the API gateway. Yeah, so you could technically have like API gateway and then have the agent talk to them. But with the agent, right, what most of the people does is they will just create MCP or like a A2A kind of protocol so that you don't have to then do the API thing, right? So if you're doing API, then I got to wrap it with the API kind of, I would say, compatible code to the agent, right? So agent accept tools, right? Or existing system accept API. So this is a slightly different methodology, right? So instead of launching an API services, nowadays people are launching MCP server or the A2A client and stuff like that. All right. So Laurent asks, how do we connect notebook with the free test platform? Okay, so how do we connect the notebook? It's fairly straightforward. Let me see, right? So this is the notebook, right? Okay, so let me go and do that. So notebook is here, right? Okay, this is a notebook, right? And how do we do that? You just click on, let's say, run in Colab, right? So just click on this one. It will actually copy the code here, right? And then you can come down here. You see there's the cloud location and project, right? So the project ID you replace, right? So the project ID that I have here is Tencel ship something, right? Tencel ship something. Just copy this, then paste it over here. Okay, then you should be able to start running. So just run. Then yeah, you should be good to go. It's like even if you cannot run it, you should be able to understand the code, right? So like here you see element agent. I'm just putting them all in the array and pass it on as a sequential agent and should be able to run it. Okay. Can I share the slides? I can share a version of it, maybe not exactly the same slide, but I will just pass that slide to you guys so that you can also reference to it. Oh, one thing, right? I was actually going to tell you about this one, right? So this is actually ADK docs. So whatever I just presented, right? You can actually find them over here, right? So you can see from here how to install it, how to get started with Python, Java, and you can see all the agents here, right? The slides and everything that I put down here is available in the documentation itself. If we go to workflow agent, you can see that the sequential agent, parallel agents, and so on. All the things are actually from here, right? So you don't have to get the slides to understand because this is actually what I copied it from, right? Like this is actually here, right? You can see from here, like this picture is actually from here, right? So yeah, this is the documentation, and I would recommend reading the documentation, right? Developer don't really like to read documentation, but you really have to read documentation for this one because things keep changing, and even for me to catch up is a little bit difficult. But I try my best to read that and then try to understand. So someone asked about thank you for saying that you're enjoying the session, how you took your time to go over rushing. Setup really important. That's right, yeah. Because if you don't set up properly, you can do a lot of trouble. Because I went through the same thing, I kind of realized that. And sometimes being able to talk to people virtually without seeing what kind of struggle they are facing is really challenging. And going through that, it actually helps a lot of people ramp up and then do the tasks. Right, the documentation link is here, ADK docs. Right, and of course, I think there's also another slide I should show, right? It's like, oh, if you have some feedback, right, feel free to scan this. And you also have the Vertex AI Studio free trials that you should scan it. And then I don't have the link for that. Maybe Bill or Azul, you have any links? Yeah, so that's pretty much what I have. And if you want to connect me with social media, here's what you can do. You can scan this. It will link to my LinkedIn. And if you have like any specific questions, you can scan this. It will link to my LinkedIn. And if you have like any specific questions, you can reach out to me from LinkedIn directly. Then I will try to answer them. And give me some time because I do need to respond to lots of people, but I will try to reply, right? So don't worry if you don't receive reply in like one day. I will try to reply as much as I can. And with that, thank you so much. I'm going to pass the time back to Bill. Thank you, Bill.
Hi, everyone. Welcome back to another Build Hour. I'm Michaela on the Startup Marketing team, and I'm here today with two members of our Solution Architecture team, Emery, live in the studio, and Brian, joining virtually to help address Q&A throughout the hour.
Hi, I'm Emery. I work as a solution architect at OpenAI supporting digital native customers on building various AI use cases, including long-running AI agents.
So today's topic is agent memory patterns, which is a very exciting topic and Emery and I's first ever build hour. So if you've been following along, we started with how to build agents from scratch using Responses API, then moved into Agent RFT, and today exploring agent memory patterns. All of the sessions are up on our YouTube channel, so definitely check them out if you want to catch up or revisit earlier builds. Though the focus on the build hour is to empower you with the best practices, tools, and AI expertise to scale your company using OpenAI APIs and models. So for today's build hour, we'll start with an introduction to context engineering, the foundation for agent memory, and then Emery will walk through several live demos covering memory patterns like reshape and fit, isolate and route, and extract and retrieve. We'll end with best practices, resources, and of course, live Q&A. On the right-hand side of the screen, you can drop questions into the Q&A box anytime during the session. Our team is monitoring both in the room and virtually to help answer throughout, and we'll save a few for the end to go through live. All right, with that, I'll hand it over to Emery to kick things off.
Thanks, Michaela. Hi, everyone. So I'll start the first part of this session with context engineering definition. So this nice definition from Andrew Karpathy, I'll start by emphasizing that the context engineering is both an art and a science. So it's art because it involves judgment. So you have to decide what matters most at a given step of reasoning or action processes. It's science because there are concrete patterns, methods, and measurable impacts to make context management more systematic and repeatable. So I'll highlight that modern LLMs don't just perform based on the model quality, but they perform based on the context you give them. In this slide, I want to talk about different disciplines that comes together to basically present the context engineering. So it is a broader discipline than any single technique like prompt engineering or retrieval. So the diagram visually represents the ecosystem of context optimization layers that together shape what the model sees and understands. So you see prompt engineering as a core principle, structured output, RAG, state and history management. Memory is also a crucial part. So using persistent or semi-persistent storage like files, databases, or memory tools to offload and retrieve key information. And all of this is contained inside the larger sphere of context engineering. So we can also connect these capabilities into different product capabilities. Here is a nice summarization slide that talks about the core principles, like why it matters, because long-running tools or long-running and tool-heavy agents bloat tokens and degrade quality via poisoning, noise, and confusion and bursting. We have three core strategies, as we discussed in the beginning, like reshape and fit, to the context window, isolate and route the right amount of context to the right agent, and extract high-quality memories to retrieve in the right time. We also have prompt and tool hygiene as a core principle, so keeping system prompts lean, clear, and well-structured. Use a small canonical set of featured examples and minimize overlapping tools and gate the tool selection. And our goal and North Star is basically aiming for the smallest high-signal context that maximize the likelihood of the desired outcome. And then in this slide is where I transition from why context engineering matters to how to actually do it in practice. So I'll frame this as a toolkit of techniques. So these are not mutually exclusive. So most real-world agent architectures combine multiple strategies depending on the use case and the context budget. So the first technique is reshape and fit. We can apply context trimming, compaction, and summarization. The second one is isolate and route. We can offload context and tools to specific sub-agents with a selective handoff. And the last bucket is extract and retrieve. We can talk about memory extraction, state management, and memory retrieval in that last bucket. When we talk about context engineering, it's essential to distinguish between short-term and long-term memory because they solve very different problems. I think we can group the first two buckets as short-term memory, which we also call as in-session techniques. And then the last bucket is long-term memory. We call it cross-session. So that means you can collect different information from multiple sessions, and you can retrieve it back in the next session or other sessions in the future. So short-term memory is all about like making the most of the context window, bringing active interaction and active conversation. And then in contrast, long-term memory is about building continuity across the sessions. Cool. So we often get excited about how powerful our agents are becoming, how AI models are getting better and better. They can handle complex tasks, route between tools, they can plan multi-step workflows. But underneath all that, there's a core bottleneck because context is finite. So every piece of information we add to the prompt instructions, conversation history, tool outputs, competes for space in a fixed token budget. And this is why it matters slide. I want to make the problem concrete here. So I'll frame it around before and after contrast. So you see two conversations, what happens with a memory on the left and what happens with memory on the right. So on the left-hand side, the user started with the issues like Wi-Fi, battery, and overheating in IT troubleshooting agent. After many turns, the agent has forgotten the earlier context. It falls back to re-asking for information that the user already gave, right? But on the right-hand side, the agent remembers the original issues. Even after many turns, it can pick up the unresolved thread. It references previous actions like firmware update, background sync, which makes it feel intelligent and reliable. So this is such a stateful behavior, which is the foundation of a long-running agent. Now I'll switch gears to failure mode. So we can group these failure modes into four categories. The first one is context burst. So you can imagine it as a sudden token spike in one of our multiple components to do the limited external control or increased calls. Context conflict, if there's any contradictory instructions or information in your context. Context poisoning, if there's an incorrect information that enters the context and propagates over the turns. It can be via summaries or memory objects, state objects you're injecting into the context. And then finally, context noise. So you can imagine it as multiple tool definitions or like way more many tool definitions coming into your context at the same time. This can be redundant or over the similar items so that can make a noise in the context. Here's a nice visualization of context burst in tool-heavy workflows. So you'll see that there will be like a specific increase in one specific turn, and you'll be injecting like large amount of tool tokens here. And then the next one is context conflict. So we can easily visualize it here. So you can imagine in one of the turns, there's a specific tool call. And here in this tool call, you see that in the system instructions that never issue a refund if warranty status is not active. But in the middle of the turn, you're also saying that it's eligible refund for VIP customers. But at the end of the turn, and your agent is responding, hey, given your urgent travel, I can issue a full refund. So this is a nice visualization or example for the specific context conflict that can be coming from one of the tool results. And the last one is context poisoning. So you can imagine it as a hallucination or something inaccurate mixed into the context in any step and propagates across different turns. So here we have a couple of possible pitfalls here. Lossy summarization edits can be causing this. If you're using a free-form note that accumulates over time, they can be contradict. And then finally, older summaries overwrite the newer ones, and you'll be basically causing any hallucinations because of the summary logic, and you'll be injecting that hallucination into the context and propagating over time. Cool. Now I'll stop sharing my screen and switch to the demo that I prepared for you, and then I'll go over some of these challenges to show you how it actually works in a real world scenario. Okay, let me share my screen. Cool. So here I prepared a demo app for this build hour. It is an IT troubleshooting agent for software solving issues, for issues related to both software and hardware. And this is a dual agent demo that lets you run two agents side by side. So that kind of logic stays inside the Next.js app, and I'll be using OpenAI Agents SDK. So we have two tools connected to that agent. One of them is get orders, and the other one is get policy. So here I can start sending a message and saying hi to both of the agents, right? And then you'll see that both of the agents are responding to my message. And then here I can say, hey, my laptop fan is making weird noises while I'm playing games. Is it normal? So here you see that the configuration for both of the agents are same. They're the same model, same reasoning level, but I'm sending the same message, and there is no memory. Basically, there is no memory configuration yet. So here you also see the context usage bars at the top. So you're seeing different type of components that is already in the context now. And I can say, hey, before that, I want to see my orders. My order number is 1, 2, 3, 4, 5. So now I'm expecting the model to make a tool call and show me the orders I have. So here you see that the order status, the items I have, is powered by a specific tool call. So as you see over time, it'll accumulating different tokens and different type of tokens here. And in the context life cycles, I'm visualizing what is happening under the hood across multiple turns. So here you see that I have 84 tokens of system instructions. My user input is increasing slowly, but the core component here is agent output that will be generated by a model. Cool. So this is a typical real world scenario. So now I also want to showcase like how context burst is happening. So I can still start with hi, and I can say, hey, this time I'm having an overheating issue on my laptop. And then the model is responding to my message, to my issue, basically. And then here it's telling me like specific instructions, and it's asking me some questions to better understand what's happening, right? And then I can say, hey, thanks. Before that, I want to see the refund policy of my MacBook Pro 2014. So while I'm sending this message, I also want to quickly show you the code and core concept of how it's working. So it's powered by OpenAI Agents SDK, and here you see the agent definition. So it's a customer support assistant. I'm having specific instructions here that I'm adding. I'm using different models here, and also I can show you the system prompt real quickly. Instructions. So it's basically, I'm saying, hey, you're a customer support assistant for devices, and then I'm using like very slight prompting and instructions for that specific agent here. So let's go back to the response. So since I asked about the specific refund policy for my MacBook Pro 2014, it's make a tool call called get refund, and it's basically returning a specific refund policy that I added before. So here you see that in between turn 2 and turn 3, there's a specific spike in the context window. So in turn 2, I had maybe around like 300, 400 tokens, but now I have more than 3,000 tokens because I am just dumping lots of information into the context. And then this is a nice example for context burst here. Instead of maybe just dumping all of this information into the context as a refund policy, I can be more careful about my tool definitions and tool outputs to basically make a decision about like what should I inject into the context. So maybe not all of these information are valuable, but as you see that I'll be injecting lots of information into the context that's visualized here in the context lifecycle tab. Cool. Now I'll stop sharing my screen and go back to the deck. So I'll continue with the next steps here. Okay. Nice. So we talked about challenges and what's going on under the hood and a specific example of context burst. So now let's talk about the solution, right? So the solution is basically managing context efficiently using different techniques such as framing, compaction, state management, memories, and make the natural step beyond prompt engineering. Again, this is also another visualization about different components in the context. So you see that across the times, it's increasing, the token counts are increasing, and these tokens can be coming from system message, user message. Maybe you might be injecting memories, or maybe you might be injecting different type of specific tokens that can be added into your context. Here I want to group AI agents in terms of context profiles. So we can group them into 3 categories. So first one is RAG-heavy assistance. So you can imagine reports, policy QA agents. In these type of agents, context is mostly dominated by retrieved knowledge and citations. The second one is tool-heavy workflows. So context is mostly dominated by frequent tool calls and return payloads. And last one is conversational concierge. So you can think about planning agents, coaching agents. And in this case, context is mostly dominated by growing dialogue history. There'll be lots of tokens in conversation history, like assistant usage tokens that scales with session lengths. And then to better understand the solution and the techniques, we can go over what is fixed in our context and what is dynamic and variable. So here you see different type of components, like usually system instructions, tool definitions, and examples, unless you're doing a RAG approach, is mostly static in the context. What is dynamic is tool results, retrieved knowledge, memories, and conversation history. So these are the nice examples for dynamic and static context and tokens. So you have a control on dynamic tokens, and you can apply different techniques to control it efficiently. So I'd like to start with prompting best practices to avoid context conflict here. You can also find it from our prompting guides and cookbooks. The first rule is being explicit and structured. We suggest you to use clear, direct language and specific enough to guide action. You should give room for planning and self-reflection. I think this is becoming more and more important with reasoning models like GPT-5. And you should avoid conflicts. So keep the tool set small and not overlapping. Don't use ambiguous definitions. Even if a human can pick a tool, the model won't either. So be careful with conflicting instructions and tool definitions. So for context noise, we talked about like many tool definitions and many tools attached into the context as an example situation. Again, you should be explicit and structured in your prompts. More tools isn't always equal to better outcomes. So favor targeted tools with clear tool decision boundaries, and then return meaningful context from your tool. So in the demo, you show that specific example of context burst. So we suggest you to control basically what is the tool output, and then return high signal, semantically useful fields, and prefer human readable identifiers. Nice. So now I'll switch gears to engineering techniques, and I'll start with the first one, which is reshape and fit. So the first technique here is context trimming. So it is a pretty basic technique. It basically means that dropping older terms while keeping the last end terms. Here in the term we have like limited context. It's getting noisy. There's lots of information in the context. It can be coming from a tool, user message, or different sources. And there's higher likelihood of losing track because we are getting close to context limit. But once we trim the older conversations, older messages, now we have fresh context. It has better attention, and you'll see that it will also increase the latency that you're using. So it basically keeps the last end messages and trims the previous older messages. And these are just some parameters, and now we have control over in context trimming. The second technique is context compaction. It basically means just dropping tool calls or tool call results from the older terms while keeping the rest of the messages. So if you have a tool-heavy agent, you can consider these techniques. You'll see that your context will be mostly dominated by tool results. It'll be noisy. There'll be maybe some context noise and lots of information coming from different tools. And after compaction, you'll see that there'll be fresh context, better attention, and faster processing. And you'll also be keeping the tool placeholders intact even after the context compaction here. And the question you might have would be like, okay, how can I decide heuristics about trimming and compaction? So here I can share a couple suggestions. So first, you can analyze your sessions. You can collect like context snapshots from production or from your users. You can collect times down and dislike context to see what's going wrong there. Think about the average token size of a context, what type of task you have in one session. Secondly, like do not trim mid-turn and break turn blocks. So a turn basically means that a user message and all the other message until the next user message, right? So if you just break or don't respect these turns, there'll be higher likelihood of losing track. And then finally, don't wait to hit context window limits. So keep track of context allocation. You can set thresholds like 40 or 80%. So if you're getting closer to hitting the context window limits, these thresholds will help you to better understand, basically, when you should trigger some of these operations. You can control tool outputs, and you can also keep track of token saves. So these techniques are also really nice for reducing cost purposes. And you can always keep track of like how much token you're saving while you're increasing the overall capability of your agent. And then the next technique we have of your agent. And then the next technique we have is context summarization. So it basically means compressing prior messages into structured summaries, and you can inject into the context history. So here in turn n, you see lots of messages, noisy context again, and you're basically keeping the last n messages and just summarizing or compressing the previous ones so that you'll have fresh context, better attention, faster processing, and at the end of the day, you'll have a golden summary. So this will be like a valuable information because you'll be basically compressing all of the valuable informations. And at the end of the day, it will have like a very dense object that you can keep track of, and it'll be also useful for you to better understand what happened in the conversation. And here's a nice visualization in the context lifecycle about the summarization. So let's say you perform the summarization in a specific turn. So you'll see that you are compressing all the previous information and injecting it back into the context as a memory object. So you see there's a new component called as memory after the summarization performed. Nice. So here's a comparison of summarization versus trimming. So there are different dimensions that you can consider while you're designing a memory pattern for your agent. You can see that in trimming, you'll just keep last end turns and you'll be dropping the oldest ones. So basically, it'll be pretty straightforward operation. So it'll be very fast. There's no latency. But the trade-off is that you might be losing some information that is already there. So I think this is the main trade-off that we have. It's really best for tool-heavy ops and short workflows. And then in summarizing, you're basically just keeping track of all the information, so you're not throwing away anything. This can add a little bit of latency and cost because you'll be doing another summarization call to a model, but you'll be just collecting all the information. So you can think about an agent or use case. If you have like multiple tasks in your long-running agent that are independent from each other, you can definitely consider trimming, because probably the trimmed or thrown away information is not important for the agent for the next turns. But if you're collecting useful information across multiple turns and tasks are dependent to each other, then you can definitely consider summarization here. Nice. So now I'll stop sharing my screen and go back to the demo. I'll show you a couple examples of these techniques that we already covered here. Let me quickly share my screen. Nice. So here, let's go to configurations page on the demo. So for agent B, I want to enable trimming, and I can basically set max turns as 3 to trigger the trimming operation. I want to keep recent turns as 3. So here I can start again to test my agent and saying hi. So this time I want to understand the refund policy that I want to check. Maybe I want to refund the laptop I just bought. I can say, hey, I want this refund policy for my MacBook about a month ago. And I want to understand like what's happening here in terms of refund. So if I'm eligible or if I'm not eligible. So the model is now making a tool call and calling the get refund tool here. As you see, it's returning that specific information. I have the return window for returning that specific laptop. And I also want to check my order. So I changed my mind and I'm saying, hey, can you also check my order? My order number is 12345. And I want to see like if it's on the way, if it's coming. So you see that the model is doing another tool call as get order. And now I want to switch gears. I can say, hey, thanks, I'm having an issue with the internet connection. So until this turn, you see that I have lots of tool tokens here in context lifecycle. So it's getting accumulating over turns. And in that specific turn, now it's telling me that, hey, let's sort it out. It's asking me a couple of questions about my device. And I can say, hey, I tried to load an internet page and still see 404 error. I basically share a couple important information about the situation, and you still see that across the turns, it's accumulating lots of tokens, and even agent output is increasing. Okay, so let's say it's still happening on Safari, and then this is the last message probably that I want to share about the current situation, and I'm waiting to have more guidance and instructions here. And here you see that at the end of turn 6, the context is trimmed. If I go back to here to visualize what's happening, so when I hit the turn 6, you see that it trimmed the context. So it basically removed all these tool outputs and tool tokens. So now I have a fresh context here, and then now I can continue talking about the same specific issue, or I can continue to talk about like different information. Nice. So let's go back, and then here I also want to show you how summarization works. So also the compaction works in a similar way as trimming. So here I can set compaction trigger as for and keep recent turns too. So you'll see that at the end of turn 2, it'll be compacting and removing all these tool outputs, and I'll have a fresh context similar to the trimming approach. But now I want to be a little bit more advanced here. So here I want to enable summarization. I want to set the summarization trigger as 5, and I want to keep the recent feature. So here I click save, and now I want to just see how it's summarizing all these information. So here I'm saying, hey, I'm having internet connection again. So this time I decided to share more and more information about my situation. So I can say where I bought this computer, what is the model. So I can say, hey, I have a 2014 MacBook Pro 14-inch, and I live in the US, but I bought it from Amsterdam. I received it from a battery chain service and just updated the OS version last week, and they asked me to update the OS version to macOS Sequoia. So as you see, I'm sharing like many information, and these informations are really valuable for an IT troubleshooting agent, right? And here I can go back and say, okay, these are nice, clarify the problem, like what I need from you, and I can say, hey, I already tried hard reset after checking the FAQ docs, but it didn't work. So this is still in a form of memory because I'm sharing like which steps I tried, which worked, and which didn't work. I can go back and continue talking with the agent. So now it's reasoning itself and providing me like more detailed guidance and instructions for specific to a MacBook. So I went back to my computer and I saw that the Wi-Fi icon is not active. And then I'm thinking maybe it's related to Wi-Fi, or maybe it's related to a specific software issue. So as you see across the turns, it's getting more complex. The agent needs to reason, and the agent also needs to keep track of what's in its context and make sure that it's not there's no burst, there's no conflict, there's no poisoning and other type of failure modes. It's telling me some specific steps, and I can say, hey, I tried it already, and I'm wondering if it's a specific software issue, right? And then here I'm waiting for a response from the agent. So again, I shared lots of information here, lots of valuable information. So now the agent knows my device, where I bought this device, which steps I tried, and basically what type of steps I performed before doing that. Cool. So now you see that it's responded to me like a very well-structured instructions, given what you described. Wi-Fi icon is not active, blah, blah. And then here I see that the context is summarized. And I noticed that there's an orange component we count as a memory item. And the memory item is basically the summary that we had. So here, between turn 4 and turn 5, you see that I'm condensing some part of the context, and I'm injecting it back as a user message as a memory component. So again, here memory is basically the summarized context from the previous turns. So now I want to go back to the code and show you the summary prompt and go over like some important topics about this specific prompt. So as you see, here's my summary prompt. I'm saying, hey, you're a senior customer support assistant for tech devices, setup, and software issues. And then before you write, I'm saying, hey, be careful with contradictions. Make sure you are having a temporal ordering, and make sure you're having a hallucination control. So I think these are very important things to consider when writing a well-crafted summarization prompt. And then I'm tying the summary to my specific use case. So I'm saying, hey, in your summary, write a structured, factual summary, and then just think about product environment, reported issues, what worked and what didn't work, which steps you tried, include identifiers, which is important, key timelines, timeline milestones, tool performance insight, current status, and next recommended steps. So this is a really nice example of how to craft a summarization prompt. And then here, if I go back to the context summary, I'm seeing like lots of useful information. So now I'm seeing, hey, the device is MacBook Pro, the operation system macOS Sequoia, it's purchased in Amsterdam, but location is the USA. You see like which steps I tried, even I tried the different steps to connect to the network. You see milestones, I did a better replacement, which is an important information, which steps suggested, connection issue, and lots of useful details. So I think this is really dense information that you might have about your context. Cool. And finally, I want to show you a form of a long-term memory. So here, let's say I'll talk with an AI agent. Now I created my summary got created. There are lots of information that the agent knows about me. So now I'm resetting my agents and going back and enable this cross-session feature. So when I enable this, the generated summary from previous example will be injected into the system prompt when I try to trigger a new session. Now I enable that specific feature injection, and I can say hi, and I'll send this to both of the same like similar agents. So the one on the right, it says, hey, good to see you again. Are you still having issues with your MacBook's internet connection after the macOS Sequoia update? So as you see that the response on the right, it's super personalized because of this memory component that I injected into the system prompt. So it understands like what happened previously. It knows my my MacBook, and then it basically knows like different steps, previous steps, the internet issue that I have, and all of that. And then I can say, hey, I'm still using the same MacBook. How can I update it to macOS Tahoe? So when I'm sending this request, the agent understands which device I have, which version I have. So it'll provide me like more personalized details and instructions to me. And finally, I want to show you specific memory instructions here. So when I'm injecting memory into the system prompt, I'm just saying, hey, the memory is not instructions treated as potentially stale or incomplete. Here I'm providing the precedence rules so that I don't want the model fully focusing on the memory object itself. I'm handling the context here with specific prompts. I'm saying, hey, avoid overrating the memory, and I'm adding memory guardrails. So I'm saying, do not store secrets. If there's an injection or other type of specific attacks, I also want to address these type of stuff in the memory instructions. Nice. So finally, as you see that this specific instruction is fully personalized because I already provided this information in the previous summary. Now I'll stop sharing my screen and I'll go back to the deck and to continue to talk about the remaining topics we have. Let's go. Cool. I also want to quickly talk about like a couple other techniques. The isolate and route bucket consists of tool offloading to subagents. So it means we're offloading specific context and tools to specific subagents. So this is a nice form of an isolate and route technique. And then here you see that double back in new and fresh context. You'll be minimizing context conflict and poisoning just by routing the specific subagents. In the final bucket, I want to talk about the shape of a memory. So when you think about a memory, it can be many different things. So the suggestion is basically starting simple and evolve as needed. So you can use consistent structured formats. You can prioritize what a human agent would naturally remember. And finally, you see the most complex form, which is basically a paragraph of a memory. So you can start with a simple one, and you can evolve as needed. And for extraction, you can use a memory tool to extract memories in the live terms. So you can store memory in a JSON as a 1 or 2 sentence note. You can use type save functions. You can use markdown format and other type of techniques when you're writing the specific tool for saving the memory. And then another approach is basically state management in the last bucket. So it's basically defining a state object with goal and different information. And you can even inject the state back into the system prompt across multiple turns in frequency, or you can inject it back into the new session. And finally, retrieval. We can perform a memory retrieval with a tool. So it's similar to a RAG approach. So you can basically store these memories into long-term store in a RetroDB. And during the live turns, you can basically like make a search, filter, rank, and inject it back into the agents. Nice. So finally, I want to wrap up. So I want to reiterate best practices in agent memory design. So first one is basically understanding your typical context, and you should define what is meaningful for you and for your agent. The second point is deciding when and how to remember and forget. So you can promote stable, reusable facts to memory and clearly forget temporarily stale or low confidence information. And you'll see that your memory will be evolving over time, and you can continuously clean, merge, and consolidate memories, and you can optimize these steps in iterations. And finally, evals is also super important. So you can run your own evals to see if there is any improvement with memory on and off. You can even build your memory-specific evals for long-running tasks and long context.
Awesome. With that, let's move on to some Q&A. We've had a ton of great questions come in. So why don't we refresh the presentation and we'll pull up the next slide and get into a few.
Nice. Okay. So let me go back to the Q&A session and jump into the questions we have. So let me quickly share it again. Nice. Okay. Yeah, let's start with the first questions. Yeah, so there are any libraries or packages to recommend for context engineering. So this demo is built by using OpenAI's Agents SDK package and library. It gives you a really good flexibility to implement your own sessions. And in these sessions, you can easily implement like trimming, compaction, summarization, and all of that type of techniques easily here. So I see many different libraries that are evolving really fast to basically make your life easier for context engineering. So as you see, we have too many techniques, and each technique has different parameters to tune. So I also see that there's an evolving part of all of these libraries. But I can suggest OpenAI Agents SDK as a starting point to basically start implementing specific context engineering techniques and go from there. Nice. Next one. So how do you evaluate or measure the memory feature is evolving? The memory is improving performance. So this is a really nice question. Yeah, after this session, you might think about, hey, I implemented a specific memory approach. I don't know if it's good or not, how it's performing well. So we can maybe split this into a couple portions. So first one is basically just running your regular evals with memory and without memory. So I think this is a really nice way to start thinking about if memory feature works or not. So if you have some specific eval metrics like completeness, like upvotes, downloads, or that type of metrics, you can see if there's an increase or decrease, or if there's a significant uplift coming from the memory. And then maybe your evals might not be capturing well that type of memory-based boost or improvement. Then I suggest you to think about more like memory-based evals. So what I mean by memory-based evals is basically evaluating the model on long-running tasks and long context. So if you're not hitting any context thresholds, maybe your agent doesn't need any of these memory improvements at all. So again, you can start with your core evals if you have already. And then secondly, you can start creating your own memory-based evals. So you can even evaluate the quality of the summary. You can evaluate the injection time. You can evaluate the injection prompt. So there are different ways to evaluate it. But of course, in most evals, you also might need to prepare a golden data set first and think about maybe like a couple 50 examples, like golden examples of a good summary. Or you can try different heuristics that I mentioned before to basically find the right balance of trimming and compacting. So I think we can just group this into 3 different buckets. First one is running your own evals to see if there's an uplift. Second one is building memory-specific evals. And the third one is basically finding the right heuristics and parameters to apply in the context engineering techniques. Next one. So should we use hierarchical context, like entire project context for immediate task and context for immediate file editing questions? So yes, the answer is yes, but it's mostly dependent on the use case. So we also have a concept called memory scope. So you can think about this memory scope as a global scope. That means if you have a customer or user of your agent, probably there's some information that you should always remember about that specific user. Maybe this user likes more friendly tones. Maybe this user lives in the US. So these are some examples for global memory. But you can also have a scope based on the specific session. So let's say I want to book a travel, and then this time I prefer window seats because I want to sleep. So this was a nice example about the session scope and session memories. So I think this is a good practice to maybe separate these into two buckets, and you can keep track of session memories with session scope, and over time you can graduate session memories into global memories, and you can keep track of like what is really important about the specific user. So in travel concierge example, if user is always saying, hey, this time I want window seat, like maybe multiple times, and you can finally graduate that memory into global memories and keep track, keep it in agent's mind basically, and remember that for the next bookings. Nice. Okay, so what strategies do you use to keep memory flash or prune so the agent doesn't become overloaded with stale order? Yeah, this is a really this is another good question. And in the real world, you see that memories are evolving really fast. So after some time, you'll see that there are some memories that you need to prune, and the agent needs to forget. So in that specific case, there are a couple of techniques to apply. So first of it is basically keeping a temporal tags. Okay, I learned this memory from the user, but I learned it maybe like 2 months ago. So if you can keep track of these timestamps or temporal tags, the model will understand what is old and what is new. So if I say I like dogs, if I said I like dogs like 2 months ago, and today I say I like cats, so you'll see that the model is going to understand my favorite animal now is maybe cats, and it will override the memory with the right instructions. So this also falls into a little bit the memory consolidation. So how to prune stale memories, how to basically update and override the new ones into the existing ones. So temporal tags is one technique that you can apply. The other one is you can use a weight decay or basically a window function, and you can basically focus more on the recent memories, and you can basically downgrade the oldest ones. So it really depends on the nature of your use case. So if you think that what I said a year ago is not important for your agent, you can definitely prune these old ones and implement a weighted average probably for all your memories. But if you think that all of this memory is equally important for your agent, then you can consider maybe like memory consolidation and memory override with temporal tags. So we can talk about two different techniques to manage the overloaded and stale memories. Nice. Okay, so how do you manage scaling agent memory systems when you have many users with individual and shared memory pools? Yeah, this is also another good example from real world. So once you see the memories are evolving over time, and you'll see that you're collecting tons of memories from your users. So there are different ways to scale it. I think the first path or first decision criteria starts with if you are basically performing a retrieval or search-based long-term memory approach, or you're just using basically summarizing the context. So if it's the second one, that means you're just storing all of this information and persist it into a disk. So you can think about some scaling methods about data management, how to manage like a large amount of memory nodes as a text in a text format. Or you can basically think about scaling the first approach, which is basically you have to think about like how to scale a search and retrieval system. You might be storing all of this information into a vector database, and then in this vector database you can try to scaling storage. You can scale all these vectors, filtering, ranking system, and all of that. So I think the first bucket is mostly about this long-term memory. So we talked about like, memory as a tool. So if you can think about extracting memories with a tool and retrieving back during the life turns, probably this is the situation where you're going to hit this question about scaling for many users. In this case, you can think about scaling techniques for vector databases. You can use sharding. You can optimize your embeddings model probably if you're using a customized embedding model. And you can basically optimize retrieval process similar to a RAG approach. Again, the first one is mostly about scaling a retrieval system. The second one is mostly about basically data storage, how to store specific data, how to manage tons of information in sentences. I think to wrap up, we can basically put it into two buckets. One of them is scaling and optimizing a retrieval system. The second one is also making more efficient for storing and persistent in the disk. So this is also a common question that I hear from my customers. I think you can maybe follow like a pilot approach, and you can turn on this new memory techniques for a subgroup of your users, and you can think about okay how it's evolving over time. Maybe you'll see that most of the memories that your users are saying are pretty limited. So think about the travel concierge agent. So probably I'll just sharing my memories about my seat preference. Maybe if you want to book a hotel, I like maybe higher floors. Maybe I like the specific menu or breakfast. So I think this is more limited type of groups, type of memory possibilities, I can say, in that type of agent. But if you're building a life coach or life coach agent, so there are tons of memories that you need to remember about me, my life, and you'll see that these type of memories and memory pools are evolving really fast. So yeah, the third point is that try to understand the evolution of memory and possibilities of memory in your AI agent. So we have two examples here, travel concierge memories and then life coach memories. So yeah, as you see in the second one, you'll be collecting tons of information that is valuable for my life, and then my dreams, my goals, what I was thinking a month ago or a year ago. So the second one is mostly like super advanced and complex, a sophisticated memory pool that requires lots of scaling for sure. Okay, so yeah, that was the end of the question, the QA session, probably.
Yeah.
Okay.
Yeah, then we can just switch to resources. So, all right, this has been awesome. To wrap things up, we've linked a few great resources here, including the Context Engineering Cookbook, which was referenced, and the Context Summarization Cookbook, and our Agents Python SDK. I know we've gotten a lot of questions on, is this available on GitHub? So you can explore all of these links on the right, and the full Build Hour repo is available on GitHub. So good news, we're likely going to squeeze one or two more of these in before the end of the year, so keep an eye out on our Build Hours page linked here. And a big thank you all so much for tuning in, and a big thanks to Emery, who's did an amazing job with this session.
Yeah, thanks everyone. We hope you enjoyed this build hour on agent memory patterns. I know we covered like lots of different techniques, lots of different information about memory, how to think about memory, how to design memory. So overall, as you see, there are too many options, but the free.
Hey everyone, welcome back to another Build Hour. I'm Christine, I'm on the startup marketing team, and today I'm here with Will and Theo. Hey, I'm Will. I'm on the engineering team building the fine-tuning product.
Yeah, and I'm Theo, solutions architect working with startups, and with Will in particular quite a lot.
So today's topic is on Agent RFT. Really exciting. So if you have been tuning into our past build hours, we did a series on agents all about how to build agents, starting with the Responses API and then working our way up to AgentKit, and now talking about Agent RFT. So all of these past build hours can be found on our YouTube. And the purpose of build hours is really to help you build on our API and use our tools. With that, I'll give you a quick snapshot now of what this next hour will be all about. So first, we are going to intro you to Agent RFT. Then we'll spend some time quickly with the task setup, and then move on to some live demos. We have a really exciting customer spotlight today with Cognition. So we'll be dialing in and then share some customer stories and then end with Q&A. So on the right side of your screen, you'll have a Q&A box. Feel free to toggle over and submit questions throughout the hour. Our team is in the room and joining in virtually to help address these questions. And then we'll save a few for the end to answer live with our team. So with that, I will pass it off to Will and Theo.
Awesome. So let's kick things off by talking about agents. So you're probably joining us today because you're building an agent for your application or your business, and you'd like to improve its performance. So what makes an agent different from a regular model is its ability to interact with the outside world to complete a task. Doesn't have to go through you all the time. We're going to talk to you. It just gets things done on its own. Now, in order to get things done, this agent has to have access to tools. So if you're building a coding agent, for example, it needs access to a terminal, a code interpreter, or maybe even an entire code base. Or if you're building a customer service agent, it might need access to internal software to look up customer records, or billing systems to issue refunds, or even the ability to escalate to a human being. So this agent needs a way to interact with your business context and the outside world to get things done through the use of tools. And the way that we think about agents here is that all their interactions with the outside world go back into the context window. So that means after looking at what it's sent into and then got out of a tool, the agent will reason to itself, call another tool, and then repeat the process.
Yeah, that's super cool. So how does that tie in with our first party products, not agents?
Yeah, totally. So we do care a lot about agents here, obviously, and we're building some of the best agents for specific use cases. And here's how OpenAI agents use tools. So for example, Codex has access to a wide range of tools to complete coding tasks end to end, like running tests, reading your code files, or making code changes. So in the case of Codex might have access to, say, a code planning tool or a terminal tool, or even a tool to apply Git patches. And another example of a first-party agent that we've released is Deep Research. It's now embedded within our agent and GP5 products. Deep Research has access to a browser. Can also look through your files and can also run code. So for Deep Research, so this set of tools allows the agent to deliver you the most up-to-date, most accurate research articles.
Yeah, that's super cool. And so when we work with customers, usually using our models, and they're interested in optimizing those models, they work a lot on prompt engineering. What would you recommend to optimize your agents?
Yeah, so prompt engineering is honestly a great way to start. We've seen many different ways to improve the performance of agents so far, so let's go through them. So as you said, you can steer model behavior by optimizing the prompt. So it's almost like instructing the model to do your task better. But let's say that you've optimized your prompt and you're still not as satisfied as you could be. So you can then optimize the task itself. For example, you can simplify the task. You can have better guardrails around the task to improve the agent's chances of getting things right. Or you can add or subtract tools even, or make the tools better at accomplishing what the agent intended to do.
Yeah, it's interesting when you look at agents because we've seen customers be successful at improving the performance of the agent just by changing the description of the tools and even their naming, just because it makes more sense. It's like semantically easier to understand for the model.
Totally, yeah. So there's a lot that you can do to improve the performance of the agent before you move to fine-tuning. But yeah, let's say you try all these approaches, but you still want better performance. So that's where fine-tuning comes in. Fine-tuning is a way to train the agent end-to-end on your task to achieve even better performance. And what we're here to talk about today is agent reinforcement. A lot that you can do to improve the performance of the agent before you move to fine-tuning. But yeah, let's say you try all these approaches, but you still want better performance. So that's where fine-tuning comes in. Fine-tuning is a way to train the agent end-to-end on your task to achieve even better performance. And what we're here to talk about today is agent reinforcement fine-tuning, or Agent RFT. Agent RFT is the way to do this. Agent RFT changes the weights of the model according to a learning signal that you can specify to teach the model what good behavior and less than good behavior look like. During training, the agent will go and explore many different ways of calling your tools to learn how it can do better and better as training progresses. And we want to remind everyone that base RFT is already a functionality in the current fine-tuning product, but you cannot use it to fine-tune agents. Agent RFT does allow you to do this. So it allows the agent to call tools while it's exploring during the rollout process, so it can learn from all possible ways of using your tools. You can also specify arbitrary reward signal through an endpoint, which we call to train the model on, so that it gets better and better in ways that matter to you. And so to summarize the benefits of Agent RFT, it first helps you improve the performance of reasoning models. It improves the agent's ability to use tools and reach the best final answer. It's also quite sample efficient, which can be really important in domains where training data is scarce. We'll talk more about specific examples when we go through the customer stories. And the process itself can result in a model that has lower latency and is better on agentic tasks.
Okay, that's really cool. When you mentioned latency, I think that's a very key point. And is it the number of reason tokens that drives the tool call, the number of tool calls, or what is it?
Yeah, totally. So yeah, let's kind of dive in a bit into the latency and ML performance and how we can improve those aspects. So one of the challenges of making agents work with your business context is that it might be very different from how we at OpenAI train our models. So if your tools look and behave the same way as, say, Codex's tools that we've trained on, or Deep Research's tools, then you're in luck, because the domain of the tools is going to be similar between the base model and the base model and your task. But your business context is most likely specific to you. So that means that your agent might not be used to using your tools in the way that is ideal. It might call a tool too many times. It might call 5 different tools, and calling one tool is better for what it was trying to do in a given moment. So using Agent RFT, you can kind of align these domains. It's possible to train a model to use far fewer tool calls to achieve the same or sometimes even better performance on a given task. That means lower latencies for you and faster experiences for your end users. This process happens naturally because we do apply light penalty to the amount of tokens a model uses to reason. Yeah, but perhaps you want to impose a like a constraint actually, because instead of this natural process of the model kind of learning how to use your tool calls and use your tokens, sometimes you want to make sure the model stays within a given tool call budget and doesn't go over that limit. So given how important tool calls are in affecting latency, this could really reduce the latency of your rollouts. So Agent RFT allows you to specify this cutoff that train the model to stay within this given budget while preserving or exceeding the original ML performance. But ultimately, you're probably here in the first place to improve the ML performance of your agents. So obviously, Agent RFT can help you do this by first training the model to reason better across tool outputs, and two, training the model to use tools better in the first place. So all this is learned organically during the exploration and rollout process, as it tries many different ways across the search space to call your tools, and then think about the outputs from your tools to arrive at a better answer. So hopefully it hill climbs well, hill climbs nicely on your task.
Yeah, that's awesome, and I really want to try it out. I want any people to try it out actually, and I know you worked so hard to make this work. So
we worked hard.
Yeah, but the whole team and your whole team is under the hood. How does it work? How does it communicate with the tools and stuff?
Yeah. So let's dive in. So in order to make all this work, we've introduced several major new updates to the existing RFT product. So first of all, it's the ability of the model to call tools during training via calls to your endpoints, so calls to your tool endpoints. And second, it's the ability for you to specify greater in the form of an endpoint that we can call to get your custom reward signal out. So these two additions mark the first time we've allowed our models to interact with the outside world during the training process, even our frontier models, through your tools as the model is exploring and doing its rollouts, and through your reward signal when we're ready to update the model. So to dive even deeper into exactly what's happening during the training process. So for each agent rollout, we assign a unique identifier to all tool calls and final answers that come out of that rollout. And when the agent calls your tools, we attach that unique ID to the tool call so that your system can recognize different tool calls as originating from the same rollout. So this can allow you to keep track of rollouts as they happen, which could be important for state management if you choose. So you can do this in your own database or your own backend. So that when we emit the final answer and then call your grader, you can then attach all the context from the agent to the final answer through that unique identifier. And then you can pass all the stuff into your grader. And you can have this like very, very holistic grading context.
Yeah, that's awesome. I think what I find the most powerful here is really that all the tool calls and the grading happens in your environment. So it can match totally your production environment, and then your model will just not be surprised when it sees that specific tool and will know how to call it. And it also gives you like so much flexibility in the grading. So currently on our platform, we have a couple of ways of grading, but here, because you receive every tool call, you can store them, you can grade them, and really shape the policy that you want for your model.
Yeah, absolutely. Totally. So there's a lot of flexibility here. And we hope Agent RFT helps you teach agents to achieve frontier performance on your tasks. So enough talk about theoretical things. Let's now illustrate how Agent RFT works with a real world example. So we're going to fine tune an agent to perform better on FinQA, financial QA, which is a benchmark that gives a model a financial report and asks it to answer questions about it that require numerical reasoning. So the original benchmark, so this is actually an academic benchmark that was published, and the original benchmark prompts include the relevant financial report that the model needs to answer the question. But we've decided to make things harder because we like doing things the most difficult way here at OpenAI. We modified the benchmark. We've made it a lot harder by only giving the model the question itself without the context, no report. And we require it to use tools like an agent would to search for the correct report in this pile of 2,800 financial reports to answer the question. And to make the task even more challenging, we require the model arrive at its answer within 10 tool calls.
Yeah, so that's so much harder because you have to know where to look into. Then once you found where to look in, you have to reason over it. And all of this in a very constrained budget.
Totally, yeah. Yeah, so here are the tools that we've given the access, we've given the agent access to. So we have a search tool, which is a semantic search tool. We have a list tool, which kind of goes through all the directories and document paths and tells you what's in the file system. And we have this like funnily named cat tool, which is kind of our engineer brain, just naming things the way we understand, but cat returns a document given path. So it's kind of like opening a document in your computer. So let's go through an example. So here's a sample question from the benchmark. The agent might call the search tool after seeing this question about answering some question about like Intel's return. So it might ask the search tool some query to try to find relevant documents and information out of it. And so the search tool might return something like this, which has a table in a text form with all the relevant numbers it needs to answer the question. And here's the grader for this task, which is how we generate reward signal for the agent's final answers. Just to keep things as simple as possible, since we've already overcomplicated things by making the benchmark harder, we use a model grader for this task. We could have used an endpoint grader, which is something that we'll cover soon. But we also could have used a string grader, which actually rewards the model for exact string matches to the ground truth, but is super brittle and can penalize the agent for minor formatting errors, like writing out $32 instead of using the dollar sign. So it's super brittle, kind of penalizes the model in ways we don't want to. So in our case, we also want to give partial credit to the agent as well for answers that are really close to the ground truth, like like rounding errors like 0.999 if the ground truth is actually 1. All right, I'm gonna hand it over to Theo to talk about the demo training process itself.
No, thank you. Well, that was a great setup. So let me dive in some code here, and just going to make sure the right screen is being shared. I'm sorry.
Yeah, take time.
Yep. All right. So here you should be seeing the code here. So the first thing that we're going to do is we're going to look into the tool server. So we're using Modal to do this because it was very fast to just set up a fast API endpoint. And we have a bit of descriptions on how to set that up. But the main idea here is that we're going to first set up a base image where it's just going to be a dead-end image, and we have fast API, Pandas, NumPy, and OpenAI. So those will be the libraries that we need to run our code and to run the tools. So and we're also going to add the corpus, the full data, all the data in the documents, so that the model can actually look into them. So here we define the different tools, and then we just look at the search tool because, as Will mentioned, it's a semantic search. So we create some embeddings, we use an OpenAI embedding model, and then we'll compute the cosine similarity. So very similar to RAG that you are probably all familiar with. And this is how we built the search tool, which is just defined here. I'm not going in depth on the other tools because List and Cat are quite straightforward. And then the way we're going to provide these tools to the platform and to the model is going to be through this list where we have the JSONs of the tools, where we have a name, which is going to be search, a URL, which is the model URL I just set up, and then a set of headers, which have an auth token, so that only I can access those endpoints.
I'll put your name in the URL. That's great, yeah.
It's mine.
Yeah, it's yours.
All right. Yeah, so that's how we set up the tools. And then we can have a look at the grader. So as Will mentioned, we're using a model grader because in the dataset, the answers don't always have the same consistency in the number of decimals, or should we put the dollar sign before, or we write dollars after. So the idea is to prevent this brittleness. We just use a model grader. And as Will mentioned, we provide some partial rewards of 0.5 if the answer is close but it's not exact. But also this allows us to provide like answer of 1 if you say 7% instead of 0.07 as an answer. So this is very important because we want to make sure we provide the right signal to the agent, or else it's not going to be able to learn what was the correct reasoning path versus what was not a good reasoning path. All right. And we're using GPT 4.1 and then the response format. And you might be familiar with this from previous build hours or RFT engagements.
Right. And I also want to remind everyone that we use a model grader here, but we also have this endpoint grader that you can call, where the endpoint grader is basically us calling your endpoint via the public internet so that you can define your custom reward signal. But in this case, for simplicity's sake, we just chose to go with a model grader.
Yeah, totally. Thank you, Will. All right. So now what do we always do before running RFT? You can imagine that we optimize the prompt, etc. And what we're going to do is we're going to run a baseline to see how GPT-5 performs. And if you remember the reinforcement fine-tuning where build hour we did with Prashant a couple months ago, we were very interested in the variance of the model. So given a specific sample, what is the variance of scores that it gets for that sample? And so I'm going to run those plots. I actually ran the model 3 times on each of the training sets. I mean, actually on each of the sample from training and validation. I'm showing validation here because it's just 100 samples, and training is 1,000 samples, which is a bit too large and hard to read. But that's the plot that you might have seen last time. I'm going to describe it again, but what does it do?
Yeah, I mean, well, I'm going to need some help interpreting this graph because there's a lot of stuff going on here. So
yeah, all right.
Take it away. Yeah, this is
for sure. So we ran each sample. So on the x-axis, you have each different sample. For each sample, we ran the model and the agent 3 times. And on the y-axis, we have the score. So if you look at each point, the red cross is the best score that it got out of the 3 runs. So if you look at this sample here, it got 0 every time. If you look at the sample at the top right, it got 1 every time. And in the middle, sometimes it got 0, sometimes it got 1, and maybe sometimes it got 0.5.
Right.
So that's for the overall. The red cross is the best. The thick blue bar, which is light blue, this is the mean over the 3 runs. And the thin blue bar is actually the variance. And when I see a plot like this, I don't think it's a great route for reinforcement fine-tuning because many of the samples do not have variance.
Okay.
But we still have a fraction of them, like probably 15% in the middle, that do have variance. And it is this variance which is going to enable the model to learn what a good reasoning path is versus what is not a good reasoning.
Yeah, totally.
And so we expect that all those samples will actually provide some signal to improve the performance of the model.
Right.
And very importantly, this is on the validation set, but you can trust me, the distribution on the training set was kind of similar.
Yeah, totally. And maybe this is a good part to talk about the compute multiplier, because the compute multiplier kind of controls the amount of exploration that the model does. And so maybe like, over 3 repeats, basically each data point is being explored 3 times, there's not enough samples to kind of hike up those 0 scores up into the blue bar region. But maybe if we set the compute multiplier higher such that we make the model explore more, maybe one of those, the model has more chances to get some like non-zero reward out of its exploration. So that's where the exploration actually really matters.
Yeah, totally. That's great. All right, so now that we've seen this, we also share a notebook, very simple, that you can run through that will allow you to run the training on our platform using our API. And okay, now let me actually go and find the examples of one of the training runs we did. All right. So now we're on the platform, the OpenAI platform that, again, you might remember it in some ways. And you can see here that this is a job that we ran. It has a number. And we're going to explore all the hyperparameters that we ran and then see the curves for rewards, for output tools, and so on. So very high level, I ran for free epochs, meaning that we go through each sample 3 times. The batch size was set to 16. And as Will mentioned, there's a compute multiplier, which is a very important number for the amount of variation that we will observe during training. And here I set it to 1.